Hello everyone. I will introduce our paper Automating Code Review Activities by Large-Scale Pre-Training, and I am Shuai from Microsoft. Code review is an essential part to the software development lifecycle, and here is a workflow in modern code review. It starts with creating a pull request by a contributor. The contributor has made some changes based on the original code, and then the reviewer will examine the code and give review comments. According to the review, the contributor will revise the code, and the reviewer will do the code review again until the code meets every requirement and the pull request will be merged into the original code. To maintain the quality of codes and products, the developers have to spend far too much time reviewing the code of their peers. So automating code review activities has been a new research direction. And previous works targeted different tasks, like predicting whether the revised code can be merged, or the review comment generation. And they use the original code and the revised code, or the revised code only as input. And their model includes the non-pre-trained LSTM or the pre-trained transformer models. But none of them designed inputs and their models for the code review scenario specifically. And in our mind, code review, in code review, the code diff is a very special code format, data format, and our model are designed for understanding code diffs. We believe that the code change is the most important part for code review activities, and the figure shows that what the reviewer will see in the real-world code review. The reviewer don't focus on the original code or the new code only, but the difference between them. And we can see the plus and the minus symbols indicating whether this code line is added or deleted. Thus, to automate code review activities, the first step is to understand the code change and its data format code diff. Compared with taking original code or the revised code as input, the code diff highlights the difference, and the code diff is shorter than input both original code and the revised code. And one thing I want to note here is, in real-world code review, reviewers give comments mostly for a single code diff, and that's how we organize our data. Then I will introduce three tasks defined from code review activities. The first task, which is a binary classification task, to predict whether a code diff needs review. Because in a pull request, there might have hundreds of code diffs, and many code diffs are in good quality or very simple and can be merged directly, while other codes might have some issues and they need review. And that leads to the second task, which is to generate the review comment based on the code diff. And after the comment is given, the model can revise the code, revise the original code according to the suggestions for the contributor. And that is the third task. And among all these tasks, we mostly focus on the review comment task because it is important for reducing the workflow of developers in code review activities. And here we only use one figure to indicate the relationship between these three tasks. But in our experiments, we trained the model on the three tasks separately. Since there exists no large-scale code review dataset, especially in the code diff format, we collect our dataset from GitHub repos. And after data pre-processing, we finally have more than 1,000 projects in the 9 programming languages, including Python, Java, Go, C++, JavaScript, C, C#, PHP, and Ruby, containing nearly 7 million code diffs. Among them, about 2.5 million include comments. And for all the three tasks we defined before, We also collect hundreds of thousands training examples for each task. And next, I will introduce our pre-trained model code reviewer. We adapt the encoder-decoder transformer framework, which is the same as the T5 framework. And we take the code diff and its corresponding comment as our input. We also design 4 pre-training tasks. And next, I will introduce the 4 pre-training tasks in detail. For the first pre-trained task is the diff tag prediction. We randomly mask the plus and minus symbols and let the model to predict them. And this task aims to understand the code diff format. The second task is the denoising code diff task. It's a common denoising task. We randomly corrupt the original code diff and let the decoder to predict them. And this task aims to understand and generate source code in the code diff format. And the third task is the denoising review comment. It's also a denoising task, but on the comment side. And the last task is the review comment generation. And this task, the encoder will take the code diff as input, and the decoder will generate its corresponding review comments. And this task can enable the model to understand the relationship between the review comment and the code diff. And here are our results on the 3 tasks. In all the 3 tasks, the code reviewer outperforms other baseline models. And we can see code reviewer outperforms by a large margin in the code change quality estimation task and in the code refinement task. But in the review comment generation task, we can see the blue score is very low for all the models, which indicates that it is a very hard task. And by some case studies, we also found that the blue score is not very suitable for this task. So we evaluate our model predictions in 2 aspects by human annotation. The first aspect is the information, which is to evaluate how much information the author can get from the comment. An expected review should be a clear comment. And the second aspect is the relevance, which is to evaluate the relevance between comment and code change. A good code review should talk about the code diff only. Both 2 aspects are scored with 1 to 5 points, and we can see our code reviewer outperforms other models on both aspects, especially in the relevance aspect, which shows that the code reviewer can model the relationship between the code diff and its comment well. So here are some case studies. This is a case to show how code reviewer performs in review comment generation task. And in this case, the code diff is talking about adding a method here. And the ground truth talks about returning an empty list instead of null here. And we can see T5, code T5 and code X output the meaningless comment. But code reviewer can output the same meaning with the reviewer. And here is a task to show how code reviewer performs in the code refinement task. And this comment asks to flip the condition in the if statement here. And we can see the code reviewer follows the comment correctly and generates the right code. But we also see the code T5 and T5 don't quite understand what to do. In summary, our work aims to automating code review activities because code review is an essential part to software development lifecycle. And our model code reviewer is the first pre-trained model that takes code diffs as input in the code review scenario. And we release a large-scale code review dataset and a high-quality benchmark dataset for evaluation in 9 programming languages. We also propose novel pre-training tasks for better code change understanding and generation. Thank you for your listening.